get started, and we will kind of see what happens with the network here. So you may have to just trust us on some of the demos, but other ones are going to work out great. So cool. So I am Kevin Nilson, and I work at Google on the Google Home team, and this is my son Andy. Andy, you want to say hi to everybody?
Hi, my name is Andy Nilson. I'm 12 years old, and I go to Bullis Charter School in Los Altos.
Cool. So what Andy and I are going to do is we're going to talk about home automation and controlling devices in your home. And we're going to take you sort of on this journey from geek, which is the geekiest stuff you can do, soldering, wiring, all the things you can do with the Raspberry Pi and doing all, working with sensors, all the way on this journey from geek to more turnkey things to this is a picture of Andy's great-grandmother. And so basically, things you can buy at the store, take them home, set them up, and enjoy them. And so really, I guess some people kind of ask, why isn't it grandfather? Because my grandfather could never do this. But my grandmother, she has the newest iPhone and everything. She's really into it. And so this is my grandmother and Andy's great-grandmother. So today in the talk, most of the stuff that we're going to do that's, all the tech side is a Raspberry Pi. And basically, we're using Raspberry Pi because it's a great little $35 device, and really what its purpose is it's a Linux computer. It has HDMI out, has USB in, and it's really great for these type of things. So it's a prototyping board for doing things. And Andy, can you tell folks, if they didn't want to use a Raspberry Pi, what else could they use?
They could also use an Arduino.
Yeah, so Arduino. And so the first thing that to talk about is, the differences between Pi and Arduino, where the Pi is really good at like low power things. Maybe you're using a battery, the Arduino is. And the Raspberry Pi that we're going to use here is better. It's higher power, more powerful. It's basically Linux. And so it allows you to write in several languages. You want to tell folks, what are we going to do today? What language mostly?
We're going to mostly use Python.
Yeah. So do you know why we're using Python? Maybe I'll answer. So the reason we're using Python is because it comes pre-installed and pre-configured. And so as I fry Raspberry Pis, I can just buy a new one and pull it out and not have to install and set up things. Otherwise, we would have done Java or some other thing. But you want to lower that barrier to entry every time you make one of these deadly mistakes that kills another Pi. So cool. So the first thing we're going to do is a little demo. And we're going to go through lots and lots of demos as we get further and further along. And as we do these demos, Andy's going to be live wiring over there, and you guys can watch and learn and hopefully get some inspiration from him. And so the first sample is really, really easy. It's really going out there and taking an LED, a breadboard, and wiring it up. And so what you see here in the picture, we got a jumper cable. That's the white cable that's kind of moving power around. We've got an LED. It has two legs. And so, Andy, can you tell folks what the difference is between the two legs?
So the longer leg is the positive, and the shorter leg is the negative.
Yeah. So if you put them backwards, it doesn't work. So remember, the longer leg is the positive. And then we've got a resistor in there. Andy, you want to tell folks what the resistor's for?
We use a resistor so that the LED doesn't break.
Yeah. So basically, it limits the power, pulls that down so that you don't end up, popping the LED there. So it'll stop working. So let's jump over to Andy, and we'll see if I have the wrong camera. Hang on, the game center. Open this guy. Just bear with us. There it is. All right, so there is our breadboard. And Andy, why don't you go ahead and wire that up? What time is it? The demos are going to work. Awesome. So what Andy did there is basically, let me see if you can get that to focus a little better, Andy. So what he's done there is, he's ran the wire. So what you'll see is this outside row out here. That is positive and negative, or positive and ground. And so he's running the power from the positive. It jumps over here to the resistor, runs through the resistor into the LED, and then into the ground. So very, very simple, straightforward way to get your Raspberry Pi sort of connected. make that a little bigger for folks so we can see it. And that's the first step. So what are we going to do next? Now we want to install a button, so some sort of sensor, right? So where you can control things. And we'll continue down this path, adding more and more. But basically the idea is when the button isn't pressed, the light's off. And when the button is pressed, we're going to go ahead and turn on that LED. So let's hop over to Andy. And then Andy, why don't you show us? So there he goes. He's pulling out that jumper cable. So now the light's off and it isn't connected. And then basically the way that the button works is the button is just like a single jumper cable that the power passes through. But basically when the button isn't pressed, the power doesn't go through it. When the button is pressed, it lets the power go through. And so there he is. He's connected the positive on the black side, passing through. Red and black colors are kind of random there. Doesn't mean positive and negative. And he presses the button, and the LED comes on. So pretty straightforward, simple. I think everybody makes sense to everybody. So show of hands, how many of you guys have done any sort of Raspberry Pi stuff? Anybody? Yeah, just about everybody. Awesome. How about home automation? Do folks have home automation? Cool. So hopefully when you guys leave, you're all going to go home and not only do some like Philips Hue kind of stuff, but hopefully you'll get your Pi out and plug it into your house. Cool. So what are we doing next? So we've got the buttons. Now we're going to work with motion, so PIR sensors. And so the PIR sensor is really cool because, these are only like about $5. We plug them in and really powerful. You can see motion all the way out, probably just about to the back of the room in this scenario. And Andy, there's 3 wires on the back of it. So I'm going to flip over so you can show folks on the camera. And why don't you tell folks what the 3 pins are there?
One's ground, the other's power, and then the other's output.
Yeah, and so basically you can power it, and why don't you go ahead and wire up the circuit here. He's pulling out the button, and he's going to put that in. And so basically with those 3 pins, one of them is to provide the power in, the other is the ground, and that's what controls and gives it power, and the other is basically like a signal telling it when there's motion and when there isn't. And so he's plugging in each of those devices, each of those, looks like that's the signal line there that's going to be used to tell the light when to turn on. And now he's going to put the positive and negative power supply there. And so cool. Let's see if it works. Great. And so basically what we have, you can see the PIR sensor here. So this guy is red when there's motion. And so now there's no motion. So go ahead and drive motion. Yep. And then what will happen is it stays for a few seconds. So basically I'll trigger motion and then 1, 2, 3, and then it goes off. And so that's the way these work. So there's motion and then I'll stop and then it turns off. And so this is really great. It lets you know when there's motion and when there isn't. But the problem is, think about if you had one of these, if you made one for the bathroom here that turned the lights on. And then the second someone goes into the stall and closes the door, the lights turn off on you. So that's not what you want. You want to be able to keep that, knowing that action happened when the motion occurred, and then keep things going. And so that's what we're going to do next. We'll jump over here and talk about how can we keep this light on for 10 seconds after motion. And so Andy, what kind of code is this again?
Python.
Python, there you go. So I'll walk through this code. It's really simple. I think any of you can definitely jump in there and do it. Andy actually wrote most of this. So the first thing is to set the mode to BCM, and I'll talk about that in a minute. We turn off some of the warnings so we don't have to deal with that. And then we've defined which port. So port 22 is where we're listening for the PIR. So the PIR is the motion sensor. And that's sort of the raw way of working with GPIO ports. The next line, that LED, goes into GPIO port 24. So we're using a library called GPIO 0. So it makes things a little bit more legible. So the LED light, we've actually got an LED class there that we're using to do that. So now what we've got is we've got this while loop, and it's almost like a main loop like you'd use in graphics that goes and checks and determines if we're going to turn the light on or not, and then it has a sleep at the bottom. And so we just put the sleep in so that it is a Linux computer, and the computer needs to do other things while your program's running, and that gives it time to do that. So let's look inside the while loop. What are we doing? We're checking if there is motion, then I'm going to keep track of the last time motion happened. And then if the LED is not lit, I'm going to go ahead and turn it on. So that's the first piece. The next part is the more complex part, where we need to determine how long has it been since there was motion to determine if we need to turn it off or not. And then basically you're adding these two numbers apart, because we have to remember, if we want it to be lit for 10 seconds, the motion sensor itself keeps it lit for 5 seconds, but then we need to add 5 more. And so that's the code for doing that. And so I'm going to jump over to Andy. So what Andy had before was it directly wired from the PIR sensor. Now he's going to wire it into these GPIO ports so that it can go into this Python code and the port 22 and the port 24 that we see here in the top. So Andy, why don't you hop in there and flip that out? And so the only wire that he's going to, that was the signal wire, and he's going to pass it into whatever, I think it was port 22, and then jump into 24, and then come back to the LED. So the reason I don't do this is because it's not funny when I make a mistake. I think it is funny, but there's sympathy when Andy makes a mistake. But I think he's got it right. And it's a little. Are we good now, Andy? Uh-oh. Uh-oh. We're getting there. Is there a light on? Did you go, the PIR, oops.
Yeah.
PIR comes in on 22, and the LED comes off at 24?
Mm-hmm.
Is it lighting up? Can't tell if it is.
No.
No. All right, well, you may have to trust us. Is it not working? No. Okay. We may have fried this Raspberry Pi in one of our travels. So it happens a lot. So anyway, the idea here, I'll go over and show you how it's wired up. We've done this at AnDevCon and done this at the GDG, and it worked well there. So we possibly have bad hardware. But anyway, so, no, that's probably it. But basically, you can see the only thing that changed is he's moved the white cable and moved the blue cable, so where it goes into the pins and out. Okay? So let's jump over to the next piece. Cool. So you'll remember from the code, the first line there talked about the GPIO mode. So there's two ways of working with Raspberry Pi. The first is the very simple board type, which is the 1, 2, 3, 4, 5, kind of in order. And basically, I think they kind of do that for younger children kind of teaching. But any of the samples you'll find on GitHub, any of the code, anywhere that you do, is doing the top one, the BCM. And that's where it's sort of random pins in random places. And that just lays out well to their wiring design, so it's easy to pull those together. But it's actually convenient because you kind of can keep your wires apart from each other when you have big hands like me. Big belly, big hands, small feet, small ears, whatever. So the next pro tip I have is the T-Cobbler. And so you'll notice, when we're working over here, we use this T-Cobbler with a ribbon cable. And so basically, what it is all the pins on the board. So if you look on the board over here, you have all these little pins. And they're kind of difficult to work with because you have to remember which one is which. And so in one of the pieces I bought like an LED array thing, and it basically gave me this little piece of paper to put over the top. So we used that for a while, but I actually like better, working with this, working with the T-Cobbler on the left, where basically you just plug in a ribbon cable and you can just switch out different pies as you break them, and it it works really, really well. They're labeled well, and then we're over on time. Otherwise, we got a backup for everything where we can just plug them in. So I probably can switch out the pie for the other demo. We'd be good to go. Cool. Another kind of pro tip. I've got a little travel Projector, because you have all this like crap on your table in your work area, and occasionally you need to know like the IP address so you can push code or whatever it is. And so I started just use a little block of wood that I do soldering on, and that's my my Debian Linux boot screen there for the Pi. So I found that to be nice to have just a little bitty travel router instead of a big monitor and things like that. Made things easier. So kind of in the same line, one of the big challenges I found when working with Pi was like having to plug monitor and keyboard into it and trying to work on it. And then like, oh, now I have to install Git on my Pi. And I wanted to eliminate it where I could just take a store-bought Raspberry Pi and start doing my work. And so all I needed to do was know its IP address, which you can kind of find from your router, or you can find however it is. And so here I've got some scripts that I did that are expect scripts, where basically I can spin commands. The one on the left is SFTP, where I'll FTP into my device and do a put to put code there. And so basically you can see I spawn off an FTP, and then I use expect to listen for AshWord. And why do we listen for AshWord? Not because it's funny and Andy laughs, but because the P sometimes is capital, sometimes it's lowercase, depends where it is. So all the examples did it this way, so it seemed reasonable. And then the username is Raspberry. Don't forget the P. And you can kind of pass through. The Pi is the username and Raspberry is the password. So we listen for the command prompt, make a directory, home automation, and then we go ahead and put our code there. And so basically by doing this, every time I change code, I run this script, and then the other script actually runs it, so we can run the code on the Raspberry Pi. So what this allowed me to do is work on my MacBook, work on Andy's MacBook, push the code to GitHub from my Mac and working in that, but then use the Raspberry Pi, which made things a lot easier. And then the next thing I did was basically using Crontab. So Crontab -E, which is like edit, and then I could go in and define basically what happens on reboot. So when it reboots, I could have done the like star type stuff, but instead there's a simple at reboot. Then basically I can tell it what script to run on startup. So I run the Python. Don't forget the ampersand at the end, so it'll run in the background. Otherwise, your Pi will never finish booting, right? I've done that before. So the next problem that we had as we were working with things is we wanted to figure out how to get more power. And so the Raspberry Pi can either provide 3.3 volts or it can provide 5 volts. It can't provide more. And so a lot of the cool LED strips that we use, like the one shown here, it needs 12 volt power. And so how do you do that? So the videos I read and the things that, I watched videos and read about it, and basically the suggestion was the quad level shifter. And my reaction was about like this. I have a stack of Raspberry Pis in the garbage can right now as a result of sending 12 volts back into my Raspberry Pi, because I am a computer science major. I am not an electrical engineer. And couldn't quite get it. I feel I had resistors how they should be, but definitely couldn't figure this out. And that's okay. So how many of you have fried a Raspberry Pi? Yeah, a couple. Bob knows how to fry a Pi. That's cool. Yeah, so we went another approach. That failed. What else can we learn? And definitely, Andy and I are not experts, but we sure had a lot of fun learning along the way. So the next thing that we tried is a relay, and this works out great. And so what the relay is you can see on the bottom here, basically what the relay does is gives you, DC or your Raspberry Pi 3.3 volt or 5 volt to control, and then you can do the AC power. So maybe before we jump into that, should we show them the? Yeah. So let's jump over to Andy before we jump in to that piece, and we'll show you the difference. So you want to power that with? Yeah, that's good. So this is what it looks like when you power it with the Raspberry Pi. So you can see, and maybe you can hold that up, the folks can see. And then show them like plugged in with a 12 volt. So instead of 5 volt, we're going to plug it in with 12 volt, and you can see it like barely can be seen by the camera, and it's really bright. And so when you're doing things with, Andy's got cool ground effects under his bed. We did stuff for Halloween that we're going to show in a little bit. You really want to get that 12 volt. And so how do we do it? We did it with a relay switch. And so, again, this is a relay switch. There across the bottom, the DC power, when the power goes through, it will pass sort of your AC power through there, right? So we've got the 110 volt AC or 120 volt AC going through there. And so the easiest way to do that is to get a cheap extension cord and cut one of the wires and then pull it out, and that's what you see up there. And so why don't we jump over to Andy, and he'll show you kind of what we built. So I was really nervous because I did shock myself with the home power twice. I did throw out the fuse at least twice more than the times I shocked myself. And so we built the blue box there, and it has the outlet that has, on the top is controlled by this switch. So why don't we show folks that? So go ahead and flip the power. Cool. We got a cool Edison bulb there that comes on. We can turn that off. And then in the middle, let's go ahead and show them this bottom one is controlled by the relay. So that's the same relay that I showed, but encased in the box. And you can see how that light comes on, and it controls the bottom outlet. So go ahead and move the light bulb down. And then you'll see when he presses the button, the light turns on. And so he's using his Raspberry Pi to control the light switch. And you can just see the indicator there with the little green light in the middle. So that's pretty cool. Those relay switches, you can get them at Fry's. They are massively expensive. They cost as much as the Pi. I think they were $40, but luckily Google helped things along, and that works out as well. So they also contributed to the stack of Pis. So I feel we're funding open source in some way. All right. So there we are. So some of you probably don't want to be an electrician. You don't want to do a bunch of wiring, wire nuts, splicing wires together, and you're possibly worried about having one of these relays under your bed at night while you sleep. And so we found this thing called the IoT Relay. It's actually made just up the road in Santa Clara, and it's basically exactly what I have kind of built, but in this little self-contained, power strip. And it's really awesome. We love it. We got several of them that we're using on different projects, and I feel really comfortable with Andy having one of those under his bed rather than the thing that I wired together. So when I first bought it, you see it has 4 outlets, so I was super excited. I was like, awesome, I can control 4 switches at once. Well, it's not really the case. You have one control input. So you see on the bottom the 2 wires coming out, that controls all 4 of them at once. But you do have 2 settings. You have the always on setting and the always off setting. And so we'll jump over and we can show you that really quick. Andy, why don't you show folks? So it looks like now he's in the default off because the light bulb isn't on. Presses his button, the light goes on, right? And then we'll switch it over to the other side. So on the other side, the second he plugs it in, the light comes on. And then when you press the button, the light will turn off. So different applications, the light goes off. So it depends on what your application is and how you want to use it. It was very convenient to have both of those. And so we basically, in a lot of our projects, will plug in multiple LED strips I've never used concurrently the off and the on at the same time. I'm sure there's some project that we could come up with, like an engineering-based design thing. We could try to make a problem that doesn't exist, but we haven't done that yet. I'm sure we will. All right, so jumping back around. So here's what Andy and I built for Halloween. You can kind of see. Hopefully my T-Mobile will work for us today. Come on, YouTube. You can do it. Here we are. Cool. So there's our pumpkin. We put LEDs inside of it, and we have random generators that flip between all the colors, and it's for a random color for a random amount of time. So you get a pretty cool kind of effect there. And then the next one is pretty cool. So what we did here is, sorry, to make that bigger. How do I get that bigger? Click that. Awesome. So what we did is, when kids walk up to the house, it looks dark, and then basically they see the pumpkin, I wave my hand, and then we flash the light back and forth it toggles between the door and the sides. And then when the kids go away, it will stop. So we haven't had motion for a little bit. It keeps going back and forth. We live on a cul-de-sac, so there's lots of kids, but they kind of peek down the cul-de-sac. And then as folks kind of walk through, now we'll do motion again, and then things kick off again. So it's kind of fun. It's a fun project. Andy and I did it. The motion sensor, a lot of people ask, is over in the right in the bush. And I put it kind of in the bush where you can't reach it, otherwise, because it has that little red light, and the kids tend to want to grab it. So you have to kid-proof your projects. Very important. So this is what it looks like on the inside. You can see the two IoT relays. That's controlling the ones in the porch. And then the Pi back in the corner over here on the top right, that's the Pi that controls the pumpkin and doing all the lights there. So pretty fun little project. So the next thing, is like, what are we going to do next? I've been told I leave the lights on, so my wife tells me that our closet lights are on every day when I go to work. I try not to, but I must be thinking about work or thinking about my family. Who knows, but probably work. And so I forget to turn those closet lights off all the time. All right, so here we are. We're in a cloud talk or an IoT talk. IoT is kind of about the clouds, but we haven't really talked about the clouds at all. And so let's do that now. This is a fun picture. Looks like Armageddon, some spaceship coming into my neighborhood. So Andy was playing at the park, and I got a fun picture there. So, although I work at Google, I actually have nothing to do with Firebase, but I actually thought it was a pretty cool tool for solving this problem. So it's somewhat of a real-time database that will do push. So it'll hold data in the cloud and then push to you. So I thought it was a great tool. My friend suggested it, and so we jumped over and we're going to use Firebase to control a bunch of lights. And so this is the Firebase console. And let's see, let me jump over to what we have here with Andy. So Andy has a red, green, and a blue light. And then basically we have the Firebase console that will let us, oops, there it is. So we have a web view here. And then over here, we have Android, and it's so incredibly small we can't see it. But basically, you can control all three, and if our network is not happy...
I just plugged it in.
Oh, you just plugged it in. Okay. We'll wait for it to boot up, and all three lights... Oh, Andy's playing with them over there on his phone. So show folks your phone. So that's the same as the simulator there. And whoops, we can't see it. I don't know what happened there, Andy. There we are. Sorry. Oh, there we go. Okay. So move that, Andy, so we can see. So it got on the network. The lights are on. Move your phone, please. Let's see the lights. Yeah. So you guys can see on my screen, I've got a little web app. I'll turn off the red, and you can see the red goes, oops, let's get this one in screen. And we need to get this one in screen. You may have to, oh, that one's pretty small. You can't really see it. But so we'll toggle red, go, blue. We'll turn them all off, and then you'll see all the LEDs come off. And so we're basically, and then Andy, why don't you turn them all on with your phone?
Oh.
Yep. So Andy turned them all on with his phone. So he's using his phone. I'm using the simulator. I'm using the website. I didn't write the iOS app yet, but that's another 10-minute project that he and I will probably do over the spring break together, so he can learn a little Swift fun. But that's basically the idea, where we've pulled everything together, and we're using Firebase to control our lights. We can plug this into the AC power and do that as well. So now, let's jump over here. So this is kind of the circuit, what it looks like. In a better picture, we have the LEDs, we have resistors for each one, and then we have this one LED, which is kind of cool, that takes all colors. And so it's a single LED that has like an RGB pin, and then you can put power into each of those to control them. I'm not sure if you can provide like varying amounts of power to each one to get like all the color, the full color spectrum, but for sure you can control RGB in a single light. And it's a little expensive, but not too bad. Cool. So what's the code look like to do the Firebase? So this is the HTML side. What do we do? So basically the first thing we want to do is is read those values from the database. This is where I'm reading from the cloud to see how to update my DOM. And then basically I read the red, so I take that snapshot, read its value of the red, the green, and the blue, and then I'll update the DOM with the value. So is the checkbox checked or not? And then how do I save a color? So actually saving the color, where when I make changes on the DOM, how do I push it forward? Basically, I check the checked of that state, and then in the same Firebase database reference to the red, I set the new value. And so if you remember from the other, let's see if I can, this thing over here, that red, green, and blue on this LED color object, that is the object that we're working with there. Cool. So now let's look at the Android code. Same idea. We get a database reference, and when a child changes, right? This is where we're reading from the cloud. When a child changes, so one of the Firebase values changed, then I go through and set the value from the snapshot there. So I read the snap.get value that you see over there. Oops, where's the? Oh well, I can't turn the thing on, but that's fine. And then basically here's how we save it. It's very, very similar kind of code. We check the button state and then get a reference to the database and then set the value of the child to do that. So there we are. All right. And then finally, the Python. How do we do in the Raspberry Pi? So the Raspberry Pi is a little bit unique where there are some libraries. There's something called FirePi, and there's another one, I forget the name of it, but I didn't want to do those because then that means I would have to, when I fried a Pi, I would have to go and, download something from GitHub and do a bunch of installation and, configuration and scripts, and I didn't really want to be in that world. And so what I'm actually doing here is polling a URL. So I have this, I'm polling and just continuing polling. And so after a while, Firebase starts to throttle me. So we may see that, oh, good, Andy unplugged it. But after a while, it starts to throttle me, and you have about a 10-second delay on your bulbs, which is fine. Or if I was going to build something that we were using at home that was controlled via the phone, via Firebase, I would just install the FirePi. But it's really easy. So here, regular Python code, you go out to that URL, this .json. And what does it look like? I think I have it up here. So that's what it returns, the .json. So the blue is false, the green, and then basically what you can do things like, Control C, sorry. So if I type green.json, then basically I would get just the value of the green. So it's kind of cool. That's what we're using to do the code here. That .json is kind of like, give me the full object. And you can do nested objects and things like that, but I didn't need it here. And then reading those values, decode out the JSON with the JSON decoder, and go from there. Cool. So we showed lots of things with Raspberry Pi, but what about, Andy's great-grandmother? What are some things for her? The first thing I'll talk about is Wemo. So we've got a little Wemo switch here, and these you just plug them in, and then you can control them with your phone. And so Andy's got one here. Why don't you go ahead and it's plugged into our fan. So go ahead and turn on our fan. So I don't know if anyone can hear it. Maybe I'll point the webcam, but anyway, it's on, and then he can flip it and it'll turn off, and then he turns it off. And so he's got an app that looks just like this. It's a pretty nice little app, pretty fun. And then the next thing I'll show is the Philips Hue. So we've got the Philips Hue light over there. You can turn it on and off. You can change all the colors and control that. And so Andy, why don't you go ahead and, yeah. So you just turn the light on. Looks like he's changing the color now. He's made it green, and he can turn it off. So everything works really well there on the Philips Hue. So the next thing I'll talk about is the if this then that. And so if this then that, has any of you guys used IFT? Yeah, most of you guys have used IFT. So if this, which is trigger, then do that, which is an action. And lots of integrations with everything from Twitter and email and all kinds of sensors and will it rain tomorrow, all those things, really awesome. And so I've got one if you mention me, so send me out, then some light will blink in Andy's room, so that's kind of fun.
It did it last night.
Did it last night? There you go. Thank you for the retweet at the party. I was at the speaker party. Andy was at home. hanging out with Chad. So the next thing I want to talk about is Google Home. So another really cool, this next sort of revolution is, you've got the Alexa from Amazon, you've got the Google Home, and be able to control things in your home or ask questions in your home. So Andy, you want to go ahead and play some music with our Google Home? You can see that?
Okay.
So I'm on the Google Home team, so it's kind of fun.
Okay, Google. Play the Beatles.
Spotify.
Our network is really slow. But there you go. Okay, go ahead and stop there, Andy. Cool. And then you can do other ask it questions, and Andy occasionally gets a little help with his homework, which I think is awesome, but the teachers think is horrible. I don't know. But it seems like the right way to go. So Google Home is awesome. So now let's look at this, this idea of Firebase. Let's look at the Google Home. Let's look at the Maker channel from IFT, and how do we sort of bring it all together. And so that's what we're going to show now. So why don't we jump over to Andy. And then Andy, why don't you go ahead and do a quick, go ahead and turn on one of the lights.
Okay. Okay, Google. Make red LED on.
Making red LED on.
Go, go, go. Oh, it did it in Firebase Console. You see the flipping, and then there it comes in the Raspberry Pi. And so that's that throttling delay. And maybe I should go through some of the code of how do we made that possible, and then we'll go back and show some more fun demos with that. And so the way that we made this possible was with the Maker channel. And so we used the Maker channel at IFT and created a recipe. And I think I'm going to hand it off to Andy. Andy, why don't you go ahead and tell folks a little bit about this recipe and how it works.
So the if this part is a trigger, so it's what you want it to respond to. It could be anything, like if you get mentioned on Twitter, if your battery drops to a certain amount, if it's going to rain. But in this case, we use the Google Assistant. So if you say, okay, Google, and then we have it, we want to say make red LED $sign. So then the $sign is a variable that can go in between the trigger and the action. So then in this case, we want to say make red LED, and then whatever you say is stored there. So then for the action, it's what you want to happen. It could be anything, like send you a text, blink the light in your son's room, or other stuff. But in this case, we use Maker channel, so we call URL. And then you see in the end it says text field. So that's actually the same thing as a $sign. So whatever you say will be put in there.
Yeah, and so I'm pretty sure I ran something on App Engine. AppSpot. So this is on App Engine. There's some Java code that calls out to Firebase, updates my Firebase database, and then basically that's what turns on our lights. And so it's pretty cool, pulling it all together, kind of circling back to, starting with what we did with the Raspberry Pi, then integrating voice, and then getting the voice to go back and control our Raspberry Pi. Cool. So this is what our kitchen table looked like for at least 2 months. So many apologies and thanks to my wife for her patience. We had many meals on the couch in the living room, and Andy enjoyed. I think Andy's favorite part was the soldering. And then you can see over in the far right, we're growing bean sprouts from another school project. We've got a paper towel with bean sprouts, and lots of fun. Soldering iron, and then you can see a pie there that's probably damaged by something. And then one of the cool projects that we did just a few weeks ago, really, just sort of wrapped it up, is Andy started doing a bunch of home automation in his room. And so basically, he wanted this sort of retro look. And why don't you tell people what kind of functions that we have here?
Okay, so all the way on the left, the top row, so on the left, that one's whether to turn the LED strip underneath my bed on. And then the one underneath that.
Oh, okay.
And then the one underneath that is if it's up, it'll flash. But it only works if the top one's on. It'll flash, but if it's down, it'll just stay
Solid. Yeah.
So then the one on the right, all the way far right, is on the top is the monitor. So I have two LED strips, one on the top and one on the bottom.
It was
so
computer monitor, so they can.
So that if you turn it on, it stays on. But then if the bottom is on, they can just go off, on, off, on. And then the middle on the top is our alarm.
It's like a security alarm.
So then when I turn it on, if the motion sensor gets motion, it'll flash in between my monitor and my bed. So then that's
Yeah.
that.
Yeah, so we have all these, and the buttons on top, we didn't do the top piece yet, so that's going to be like a wake-up alarm. And kind of funny comment, I said, but Andy, don't we want to have a different setting on the weekend so we can sleep in? And Andy's comment was, because I'm like, we don't want to wake up at 7 on Saturday. And Andy said, the best part about the weekend is that we can get up early. So I thought that was, that's my life, and the kids
Yeah.
come and, yeah.
Because you get up early to play video games.
Yes. So there you go. So I'm trying to sleep in and 3 boys. Anyway, so this is what it looks like on the inside. Lots and lots of wires over to the breadboard. You can see the relay switch. This is us setting it up on the kitchen table. This is me trying to squeeze all the wires into the case. We bought the cool looking case actually at Fry's. So it's pretty cheap, 16 bucks. Able to buy that. Here's Andy putting the ground effects under his bed frame with the little guy in the corner playing with his Legos, and putting those strips underneath all go through. And with that, many thanks everybody for coming. Cool, awesome. Well done. So one quick note, I am hiring for folks to do work with home automation and all the partners at Google. And so definitely if you're interested in working at Google or whatever, feel free to come and say hi, and I can tell you more about that. And definitely, we would love your feedback. Don't rate me, rate Andy. So if you think Andy did a great job up here, please go and give him 5 stars. Yeah. Cool. Yeah. Thanks, everybody. Yeah. I think I don't know if you cut the mustard, Chet.
I don't know how they let me in.
Cool. Wow. I missed there was like a really quick run through on the Google Home. Is that like standard APIs you were calling for actions now?
So there's actions on Google,
Yeah.
and in IFT, they have, it's just a...
I missed what it was.
Oh, sure, I'll just show you. Right here.
All right, Dad, our talk takes like
So-
2 minutes or so.
It's if this.
Yeah.
Oh, shit, you can't read it. You can read it here. You can't really read it.
Is this what?
What do you want to say? Make this LED $. So I say on or off. And then basically the next screen in the UI is, I picked the maker channel. I could have said turn on the microwave. I could have said, I can have it do any action. Send a tweet out. I could say like, okay, Google, send a tweet, I love Chet, and then a tweet would go out. So the actions are this. So I'm using a maker channel, and the maker channel lets you call a URL.
Okay.
So I go to AppSpot. Once I get that text field is the variable.
Okay.
Once I get that, I can do,
Okay.
I can call Firebase, I can do whatever I want.
If this, then that is a framework to somebody. Is that a Google thing layered?
No, it's a startup that supports, oh my God, they support like 100. They do Alexa, they do Philips Hues, they do washing machines, they do, so anybody who's like in the maker space, yeah, anybody who's in the maker space, they do everything with that.
And how do you connect this IFTTT with Google Home? It's plugged in, it's...
So you define an action, and basically there's an OAuth link when you define, if you go into IFT and you say, I want a new action, or I want a new recipe, and then what is your trigger? So the trigger could be your Android battery got low. It could be somebody tweeted you, or it could be an action on Google, which is the voice stuff. Okay. So then you select action on Google. It'll do an OAuth linking to make sure that your IFT account is the same as your Google Home account.
So the IFT will connect to Google Home?
Yeah.
Okay.
Yep.
Is it on all connected devices, or is it
All connected devices. This one is specific to my Gaia ID.
Well, so for example, I have my account on my phone. I also have it on my Google Home.
Yeah.
Is
Then
it
you're,
a trigger on both of those? Is it account-wide or is it device-specific?
if you used Assistant, if you said like, okay, Google, make the lights on,
I
it
can't
would turn
find
your
your
lights
Wi-Fi
on.
network.
Yeah.
You can
Yeah.
microphone off.
Yep, and so we have 5 of these things in our house,
Yeah.
and we can turn the lights on and off from anywhere and control this stuff. So it's pretty cool. Yeah, yeah,
That was really nice.
yeah. Hope you
So-
enjoyed it.
I like IoT a lot.
Yeah.
I have some recipes on it.
Yeah.
But the knowledge that I don't have is about microelectronics.
Ah,
So my question is, what would be a good resource to start learning?
I
Because-
started with for myself, I don't know much. I know nothing, right? I hardly know anything. But I started with like, what problem am I trying to solve? And then
Because I got-
search for that problem, and then I would find somebody's solution, and then just sort of, slowly push into that. Yeah.
Yeah, I got a pie as a gift.
Mhm.
And I opened it, but I never used it. Just thinking
Oh,
about
yeah,
problems I
yeah.
had.
Hopefully this may give
Yeah,
you some ideas.
definitely.
Because you have all the sensors, the buttons, the motion sensors,
Yeah.
there's temperature sensors. I just went to a hackathon where they were using a methane sensor
With Arduino.
to trigger an air freshener.
Keep up the great work. Nice job.
So if my wife saw that, we would have one at home as well. So
That would be
that was
smart.
the Febreze hack. So Febreze ran a hackathon, and that was what I thought was like kind of an interesting
It was
take.
the best idea.
Yeah, they would do things like they would use the device to turn on the fan in the Nest thermostat and spray the air freshener so that it spreads throughout the home well, and it's, yeah, it seems like pretty good.
It's like the best idea of them all.
Yeah,
So what are you seriously hiring for Google?
absolutely. I have
What
at least,
positions you have,
well, I have one of them that's working with Philips Hue, Wemo, whoever, to make the integrations work. I have like 5 openings right now that would all report to me, so different teams. You send me an email, I can tell you info.
Sure.
Yeah.
All right, appreciate it.
Yeah, cool.
Thank you very much.
Thank
Good
you.
job.
Yeah,
Thank you.
yeah. So what do you think, Bob?
It was good.
Yeah,
I liked it.
kind of fun. Try to get Andy involved. Yeah,
Yeah,
Yeah.
no, it's always nice to have
Yeah.
the young ones involved.
yeah.